For question number 1, we have to find the dimension of the can that would require the least amount of material. So we have to use a formula of surface area of cylinder. So A is equal to 2 pi r square plus 2 pi rh. From the question also, it is mentioned that the volume of the cylinder can hold up to 475 milliliter. So we can assume that 475 milliliter is equal to 475 centimeter cube. Okay, next, the formula of volume is equal to pi r square h, and it is equal to 475. Okay, from this formula, we can express h in terms of r, where h is equal to 475 over pi r square. Next, we have to put the h into this formula, where a is equal to 2 pi r square plus 2 pi r 475 over pi r square. Next, we simplify it. 950 over r. Okay, after that, we have to do the first derivative to get the critical point. So dA over dr is equal to 4 pi r minus 950 over r square. Next, we let dA over dr is equal to 0. So we will get 4 pi r minus 950 over r square is equal to 0. 4 pi r cube minus 950 is equal to 0. And we can get r is 950 over 4 pi. And this r is approximately equal to 4.228 centimeter. After we get r, we can sub r into h, where h is equal to 475 over pi. R is 4.228 square. And we will get h is equal to 8.458 centimeter. Next, we have to do the second derivative. So d squared a over dr square is equal to 4 pi plus 1900 over r cube. Then we sub the r, 4 pi plus 1900 over r is 4.228. We will get 37. 37 is greater than 0. This is showing that A, which is the surface area, is minimum when r is equal to 4.228 centimeter. Okay, now we can complete the formula of the surface area, where A is equal to 2 pi r square plus 2 pi rh. Then we have to sub all of the answer that we get. 4.228 8.458, and we will get 337 centimeter square.
Alright, let's move on to the second question. So to sum up, the question asks about what are the dimensions and volume of a square base box with greatest volume under this condition, which the condition is total sum of length, width and height not exceed 120 inches. So first, let's draw the visual of what the question wants. So this is the visualized box that I draw to answer the question better. So based on this box, I let x equals to width and length because it's a square base box, and I let y as the height. So first, we know that from the question, total sum of length, width and height cannot exceed 120. So that's why I use 2x plus y less than or equal to 120, because the question said that total sum of length, which is this plus this plus this, cannot exceed 120. So because the question wants the greatest volume, does 2x plus y equal to 120? Because we know that 120 can make our answer become greatest volume. So I let y as the subject, and it became y equal to 120 minus 2x. Next, so the formula of volume is equal to x squared y, and we already know the value of y in terms of x. So we substitute that into the formula of volume, and we get 120x squared minus 2x cubed. Alright, so after that, we have to find a critical point, and we know that when the volume differentiates and it equal to 0, it will have a critical point. So that's why I differentiate the volume in terms of x, and I get 240x minus 6x squared. So we equal that to 0, and we get two value of x, which is 40 and 0. So first, let's to know that we are on the right track, which is we want to find the maximum volume which the question wants. So we use second derivative to see whether the volume is maximum or minimum. So we differentiate it another times, and we get 240 minus 12x, and we substitute x equals to 40 into the equation, and we get negative 240, which is less than 0, and we know that we are on the right track. When the differentiation is less than 0, it will become a maximum point. So back to the value of x, so we have two values of x, which is x equal to 40 and x equal to 0. Why do I reject the answer of x equal to 0? Is because if we substitute x equal to 0 into this equation, we will get 240, which is higher than 0, and that will become the minimum point of the volume. So we want the maximum point, not the minimum point, so we reject x equal to 0, and we take x equals to 40 as the answer. So next is we just substitute back x equal to 40 into the first equation that we did, which is this one. So we substitute back, and we got 40, which is the value of y. And lastly, the question wants the volume and dimension of a square base box. So first we find the value of volume, which we use the formula of x squared y, and we substitute the value of x and y into the equation, which is both of them are 40, and we got the answer 64,000 units per square. Next, we want to find the dimensions or surface area of a square base box by using the formula of 2x squared plus 4xy. So where do I get 2x squared plus 4xy? So let's look at the drawing that I drew. So the red one is a square surface area, and the blue one is rectangular surface area. So here we can see that there are two square surface area, and 4, 1, 2, 3, and the front part we have 4 rectangular surface area. So that's why we have 2x squared plus 4xy as the formula, and we substitute the value of x and y, and we get 9,600 unit per square.
Question 5 sounds like this. Find the largest trapezoid that can be inscribed in the circle with a radius of 5 cm so that its base is equal to the diameter of the circle. Okay. So the first one we need to represent is as this diagram with a trapezoid inside the circle. The maximum trapezoid can touch the circle as it is like a tangent. So this point is x and y, and it's already mentioned that the radius of the circle is 5 cm. So the first things that we need to understand is equation of a circle. If you don't remember, it's hard for you to answer these questions. So the equation of a circle is x minus h square plus y minus k square equals to r square. H and k is the coordinate of the center, which is 0 and 0, and the radius is 5. So we can just insert the coordinate and the radius inside the equation of circle. So we will get x minus 0 square plus y minus 0 square equals to 5 square. So x square plus y square equals to 25, which we can call it as a constraint equation. So we need to factorize the equation until we get y square in terms of y square. So as we already know, area of trapezoid is half times b1 times its bases, sum of its parallel bases, and times height. So just insert it in the equation of area of trapezoid. We got a equals to half times 10 plus 2x times y. We simplify it as a equals to 5 plus x times y, which is the constraint objective equation. So in order to relate with the y squared, we need to square the objective equation, and we got a square equals to y plus x square times y square, which is y square is already stated there. So by using product rule, we can derive the x square. So after you find the u and v, we just do the product rule as usual, and you will get 5 plus x minus 4x square minus 10x plus 15. So in order to for us to find the maximum area of a trapezoid, first one we need to find the critical point, which is dv dx, or we can call it as a2 prime, a square prime equals to 0. So a square prime, we got this equation in this whole equation here. So we simplify it into this, this one and this one. So after you simplify and get the roots, there is a critical point that you need to find which one is the maximum point. Okay, next, by using the second derivative is the final method to determine the maximum area of trapezoid. The same way as before, you need to do product rule to find the second derivative. So after you do the second derivative, you will get negative 12x squared minus 16x. So next, we just insert the critical point into the second derivative equation. We will get negative 2 to 5, which is less than 0, and we got 0, which is the minimum. We want the maximum, so we take x. So we choose x equals to 5 over 2 and insert it on the s squared equation, which is the area of trapezoid. After you insert it, you need to find the a by square root both sides. So the largest of trapezoid that we could find is 75 sec 3 over 4 cm square. That's all from me. Thank you.